Hi, welcome to this video on material stock definition. Before you can use the solid simulation, you need to define the material stock. Now we do this using the toolbar button here called material stock, and this is in fact a submenu. So if I click it, you see we've got a number of choices here. The first one is auto cube. This defines a box that encloses all the toolpaths currently visible. The second choice is from STL model. So if we had an STL model, we could select that and convert it to material stock. And the third way of doing it is to extrude contours. So we can draw some shapes, any shape we want, and then extrude that to a depth. There's no limit to the number of contours you can extrude in one go, and you can have contours within contours, effectively leaving holes in the material stock. And lastly, we can then edit the Z depths of the material stock that we've extruded. So let's just go ahead and choose the auto cube and you can see what happens. So I click that, zoom all, and you can see now we've got a blue box surrounding the toolpath, and if I highlight it, it turns orangey colour to let us know that we've highlighted that. And we can select this by left clicking as you can with any other object. So I'll just deselect that by clicking it. The first thing I just want to show you is at the bottom of the material stock menu, we've got show, transparent and hide. So the default is transparent, and you can see it's transparent because we can see the toolpath inside of the material stock. If we choose show, that's now solid, but you can't see the toolpath inside. And then lastly, hide. If you just don't want the material stock in the way, then just hide it. But it's important to remember that when we do go into solid simulation, so let me just quickly do that, the material stock will be displayed. So the two separate ways there of controlling the visual representation of the material stock. If you just want it out of the way for when you're creating a toolpath, then just hide it, but it's still there. But you can in fact hide it within the solid simulation by choosing hide, but typically you would have that set to show. So let's just put that back to transparent so we can see the material stock there. Now I'm going to delete this material stock now and create another material stock from contours. So select that, left click, and then right click and choose delete. So let's go ahead and create some offsets on this gear housing here. Let's go to the top view. So I'm going to choose the offset command here. Let's say I want an offset of 5 from that outside contour there on the outside. And then let's put an offset on that bore and on that bore. And so now let's extrude these contours. So choose extrude contours, select that one there, that one and that one. And then we need to choose the depth here. It will pull up some default values for you based on the toolpaths. So we're just going to set that to 25 and then click apply. So now you can see the material stock there. Let's just go ahead and suppress those toolpaths so we can see what's going on. So there you go, so you can see the material stock there with 2 holes in it. And that's basically how you extrude the contours. Now, if we wanted to change the depth of the contours, we just choose Edit Z Values, click the contour to highlight it, and then let's say we wanted it 30 deep, choose Apply. As you can see now, it's slightly deeper than it was before. Now, lastly, we could create material stock from an STL model. So I happen to have one here open. So that's an STL model. That could well be a casting for the gear housing that we've just seen. As it's an STL model, we can look at the wireframe so you can see that it's just a series of triangles. Let's put the shaded view on. So now we choose from STL model, highlight it, left click, and it's already turned blue, so we know now that that is material stock, and we can control the visibility through the hide command now. So that's basically it. So now you've defined the material stock, you can go ahead and perform the solid simulation. Thank you very much.